Every building you've ever walked into was designed to never fail. This one is sinking and tilting 16 inches and counting. And the reason almost always starts with something nobody sees, what's underneath. Hi, my name's Carlos. I'm not an on-camera guy. You're not going to see my face on this channel, and that's on purpose. What I want you to pay attention to is what's actually underneath the buildings we live and work in, not me. But you should know where this is coming from. I spent the last 7 years as a geotechnical and construction material testing engineer, which is a long way of saying before a building goes up, I'm one of the people who checks whether the ground underneath it can actually hold it. That's what this channel is. Every video, I take a real failure or a real geotechnical concept most people never hear about and break down what actually happened underground using the same reasoning I used professionally for 7 years, not sensationalized, not guessing. We'll cover why a 60-story tower in San Francisco is sinking into its own foundation, why the ground can turn into liquid during an earthquake, and why a $20 soil test might have prevented a $200 million disaster. We will discuss everyday terms like bearing capacity, settlement, and soil classification. These terms quietly decide whether a structure stands or falls. Here's the thing, the ground is never neutral. Every building on earth is a bet that someone gambled. Most of the time, that bet pays off. You never hear about those buildings. When it goes wrong, it's almost never bad luck. It's a decision. I want to show you what that decision actually looks like. I've worked on over 500 geotechnical and material testing projects. I've been on site for drilling programs, watched compaction testing in real time, and sat in rooms where developers had to decide whether a piece of land was even safe to build on. And here's what 7 years of that taught me. Almost every major building failure you've ever heard about traces back to a decision that got made or skipped before the first shovel ever hit the ground. I remember a subgrade evaluation for a retirement committee. At one corner of the site, I pushed a hand probe into the soil and it sank straight down to the handles. Almost no resistance at all. Never a good sign. So I brought out a dynamic cone penetrometer, DCP. It measures soil strength by counting how many hammer blows it takes to drive a cone in the ground. We needed a reading equivalent to roughly 2,500 pounds per square foot to build there safely. What we got in some spots was recorded as WOH, weight of hammer. That means the cone, the bottom of the DCP, sank on the subgrade. That means the DCP sank on the ground before a single hammer strike, nowhere close to what we needed. I recommended an undercut, dig 2 feet down, remove the weak material and retest. We dug, we retested, and it failed again. So we went down another foot, tested, failed again. At 4 feet down, we finally found out why the material was weak. Buried under that corner of the site was an entire tree trunk. Whoever cleared that lot years earlier never removed it. They just buried it and built the grading over the top of it. As it slowly decomposed underground, it left behind exactly the kind of soft, unpredictable soil that kept failing test after test. We had to physically remove that trunk before the subgrade could be even approved for backfill. And that's the part about this job nobody tells you about. Sometimes the answer isn't a complicated equation. It's a piece of wood somebody buried decades ago, quietly waiting to become someone else's problem. If this sounds like something that interests you, press subscribe because we're going to explore the fascinating world of geotechnical engineering and uncover why structures like the Millennium Tower, the Leaning Tower of Pisa, the Transcona Grain Elevator, the Empress Hotel, and many others experience foundation problems, and more importantly, what engineers have learned from them.